Hey guys, my name is Sandeep Patel. I'm founder of Slotify.ca. In this video, we are going to learn important problem solving technique called recursion, right? And we are doing it for arrays only. So how do you solve problem using recursion, right? So basically there are two steps. You break the problem into subproblems, and second step is to solve the smallest subproblem, right? So how do we do this? Like, I know a lot of people talk about breaking down the problem, but they don't actually talk about how we can break the problem, right? So in this video, to be we are going to understand in depth about how we can break the problem down into subproblem and then solve those subproblems, right? Um, and we will take like 10 different array example, like most ask interview question, and then we will solve them using recursion. All right, so in case of array, you have to understand that recursion is like driving on a straight road, right? When you are given an array, there are two choices, right? You can either go in the forward direction, I mean from the start to end, or you can go in the backward direction, which means you can go from the backward from end to start, right? So there are two ways in the array you can go, right, either you can go in the from start to end or end to start. So that's the idea. Let's go. All right, so we understand the recursion in the depth now, right? So there are two ways you can solve recursion problems. Either you can go in the forward direction, that approach is called head tail approach, right? Or you can solve using tail to head approach, which is coming from backward to the front, right? So let's take a look at an example here, right? So this piece of code uh, showing the example of head to tail approach, right? So let's say that you're given an array which has elements 1, 2, 3, 4, right? So in this function, this array, we're passing 1, 2, 3, 4, right? So when we are trying to solve a problem, we need to break the problem into subproblem, right? So pretty much breaking the entire array into subproblems. And how do we do that? Like, we will reduce one element at a time. We will break the array into smaller elements, right? So for example, let me show the example here. Okay, so let's say that, sorry, let's say that in the first call, right, when you call this function first time, right, you call head to tail function, you pass 1, 2, 3, 4 inside, right? Okay, so now what happens? You go inside and now you break the problem again, right? Don't think about this statement for now. I'll get to that in a second. So let's say that we reduce this array slice, right? In the head to tail approach, you remove the first element, right? So once you remove the first element, you call the same function again, right? So in this case, you're calling the same function again by removing the first element. So now um, the problem is smaller, right? And now when you pass this, you remove the first element, and again you call the next function, right? By passing a smaller problem, right? So now your problem is shrinking, right? And then lastly, you break them down into it, like you have only one element left in the array, right? So that would be the last case. If you continuously breaking down, you may go infinite, right? But at some point we have to break, right? We have to terminate. So that's where the base case comes, right? So base case is basically existing to exit the recursion, right? So it's a strategy to exit recursion. Otherwise, you can go infinite loop, right? So let's go back here. So this is a recursive case. So in case of array, let's say when you decide head to tail approach, so in that approach, you have to remember, right, two things: the base case and recursive case, right? So the recursive case in head to tail, basically you want to remove the head and call the same function recursively, right? So that's the recursive case. And the base case is, when do you want to stop, right? You need a point to stop, otherwise this code will go in infinite loop, right? So let's say that when you call the function with 1 2 3 4, then it shrink the problem by removing the head, and then at last you have only a single element graph, right? When array size become 1, you want to exit. And how do you exit? You just return that element, right? You return that first element, in this case 4, right? So what we did here is that we call this function by removing the head, then call this, and at the end we return. So when you return, you have to remove this, right? So now you remove this step, right? You return 4 here, right? Now you remove this step, you return 4 here, right? Because all we do is we return what we get from this base case, right? So we return 4, then again we return 4 until we get to the first step, right? Like this is the first step, this where we initially started, right? So at the end you're returning 4, right? The last element in the array. So that's the approach when you take the head to tail approach, right? What about the tail to head approach? So in that tail to head approach, you basically slice the last element in the array, right? For example, you pass, so this, assume that this is tail to head function call, right? Just ignore this name head to tail, right? I think I forgot it there. But let's say that in this function you are passing 1 2 3 4, right? So your goal is to remove the last element. So you remove the last element and you call the same function again, tail to head, right? Now the 4 is removed from the end. Again, you remove the end, and then you cut to the point where you have a single element in the array, right? And then you have this base case that covers your case when you have single element in the array. You're returning that. So in this case we're returning 1, right? Because 1 is the last element in the array, right? So we're returning 1, right? So from here we basically remove the call stack, right? So we're returning 1 here. From this we return 1 here, 1 here, 1 here, and at the end the answer would be 1, right? So this is how you can use recursion, right? So you have to remember there are two approaches, head to tail and tail to head. You can either start from start and removing the element one by one, or you can start from the tail and removing element from the end until you hit the length equals 1. What is the time and space complexity of this code, right? So in terms of time complexity, what we can say here is that like this takes 1 unit of time, right? And this function call itself until when? Until the size of array, which is n. Let's say the array size is n, right? So we're calling this function n times, right? You can check here. It's 1 2 3 4, right? So we're calling 4 times. And then we return from the base case, right? So when you call a function n time, this is similar to a for loop that is running from 0 to n, right? It's the same thing, but we're running through the recursion, right? So the time complexity would be O of n. And how about the space complexity? So in space complexity, we count variables or call stack, right? So in this function, we're not using any extra variables, right? That depends on input. But we do use a recursion, right? And recursion are count toward call stack, right? We basically are calling the same function by adding more call stack calls to the stack, right? So the call stack does count towards space complexity. In this case, we're calling n times, right? So there are n element in the stack, right? And that is count toward the space complexity, and that's the reason why the complexity of this code is O of n, the space complexity. Alright, so let's solve one problem, and then we can then solve 9 other problems, right? Okay, so first thing you remember that in this function, even though we're removing the head, we are not using the head, right? Like, I mean, we're just discarding the first element, but we're not using that element to do something useful, right? But in the next problem, we are going to use that head, and you'll see why this approach is useful. All right, so let's say that there's a problem that we are given, right? It says that given array size of n, you need to sum of all elements, right? For example, if array is given like this, 1 2 3 4, the sum of 1 2 3 4 would be 10, right? So how do we do that, right? So we will do it using head to tail approach, using recursion, right? So idea is that, like, each time we will reduce a problem, right? We will remove the head, right? And then create the sub problems, right? So we break down we break the problem into sub problems, and then what would be the smallest sub problem that we can solve is the length of the array element becomes 0 or 1, right? That's a base case. So the base case are the smallest problem that you can solve, right? And then you use those sub problem to solve the bigger problems, right? So for example, let's say that there's a sum function, right? Let's say this is a sum function. We're passing 1 2 3 4, right? Now our first goal is, in the head to tail approach, is that we use the head. So this is the head, right? And because we want to do sum, we use the sum operator, right? And then we use this recursion case, right? What's the recursion case? That will pass the remaining element and call this same function recursively, right? And when do we stop? So we should stop when array element becomes 1, right? So let's say that this is our full array. We remove 1 from this array, and then we call the next function. Now pay close attention to this line, right? We are using the array's first element. In this case, even though we removed 1, but the first element of this array is 1, so we're using that, and then we're shrinking the problem into sub problem, right? Then we remove 1, right? And now we use this first element, right? And then we remove this first element, right? And same thing here, we use the first element, and then we sum of the rest element, right? So this is head and this is tail, and there's one point where you have only single element left, right? So in that case, what you do is you return that single element, right? So this is the case here. When array length becomes 1, you return that element, right? And there's also another base case, right? What if there's array length is less than equals 0, right? In that case, the array is empty. You can return 0, right? Let's say when array is empty, you return 0. So in that case, you're basically returning 4, because 0 doesn't count, right? So the last call for the array when element becomes 0, when array has no element, it returns 0. So there are two base cases here, right? So you can have multiple base cases, it doesn't matter, right? So at this point, we can either return from here, right? This is the base case, or when array length becomes 0. In this case, we're not gonna hit this base case, right? Because we're slicing problem, and at this point, we're gonna go. At one point, we're gonna shrink our array down to 1 element, right? And then it's going to return. But in case somebody passes a blank array, then we return directly from this step, right? So this is a good use case also that needs to be covered. So I hope you understand the concept of the recursion here, right? Let's solve the 9 remaining problems so that we can understand more in depth. Okay, so we have another problem where we need to do a product of array elements, right? So let's say that so I think product of array element is the same. Instead of plus operation, we will just add like product operation, right? So let's not let's not use this example. Let's use example called find maximum from the array, right? What is the highest element from the array, right? So let's create a function called find max, right? We pass array, and then what we want to return is the element that is higher, right? And let's cover some use cases, right? Console.log. So let's say find max. Let's say if we are given array of 1, 3, 5, and 65, right? So what is the higher element in this array? 65, right? So we should expect that it's returning 65, right? We also want to cover the base case where somebody passed a blank array, right? In that case, what should happen, right? So let's say that in case somebody pass a empty array, we can return -1, right? So let's cover the base case first, right? So base case 1, when array is empty, right? So let's say if array dot length less than equals 0, we return -1, right? So that covers this use case, right? If we run this code, we'll see that it's going to return -1. But we need to also cover the case where when we break this array into a smaller problem, and then once it has a smaller size, let's say the array length would be 1, what would happen in that case, right? So in base case 2, single element, right? So when we find a single element, let's say array dot length triples equals 1, in that case we will just return that element, right? Because there's nothing else we can do here. And now we need a recursive case, right? Recursive case. In recursive case, call the same function by removing head, right? So that's our idea in head to tail approach. So return, you call find max function, and then you want to slice the array from the beginning, right? All right, so now think about this. We solved this problem, right? We're calling the same function, but our goal is to find the maximum in the array, right? So how do we do that, right? So let's say that this is the array, right? So right now what we're doing is we're slicing element, right? So let's say we pass 1, 3, 5, 65, right? So these conditions are not met because array size is greater than 1. So it's going to reduce, so it's going to remove 1, right? And then it's going to call the same function again, 3, 5, 65, right? Then again 5, 65, and then 65. So last element, so we're going to return from this. So this function will just return 65 if you run this code, right? But that's not what we want, right? What if this 65 is somewhere in the middle, right? Like here, right? Then we're returning the wrong element, right? This is not a maximum in the array. Okay, so how do we do that? So if you remember the head to tail approach, we're removing the first element, but we're not doing anything useful here. So what we can do here is that we use math.max function, right? And what this function does is it takes two element, right? So in this case, let's say the first element that we discarded, we used that and we compared that element with the rest of the elements in the array, right? So now what happens is it's gonna compare this one with remaining, and then once we hit this, it's gonna compare with the remaining, right? And at one point we get 65 as the max value, right? So when we run this code, you get what you want, right? So this is the idea of finding maximum from the array. So this two step, we're gonna keep the same step in different problems as well, right? It's gonna stay same. Even this line of code remains same, right? So let's solve another problem. So let's say that we rename this function to contains, and what we want is we want to find a target element. Let's say target number, right? And when we call the same function, we have to pass the same target, right? So idea is that we want to, let's say we want to find 3, and this function should return the boolean value, right? I'm gonna comment this out for now. So what we want to find here is that if given this array, we need to find if this target element is within the array. For example, we want to find if 75 exists in this array, right? And when array is given, let's 75, right? Same example. So in this case, we see that 75 does not exist in the array, right? So this should return false, right? Let's say we take another use case. Let's say 65, right? So it does exist in the array, so this should return true. And in case of invalid array, we just want to return false, right? Okay, so before we were returning -1, we just returned false, right? Because we want to cover that use case where array length is invalid. So that covers this case, right? Another base case that we want to cover is what if when we break down the problem and array becomes single size, what happened at that point, right? So when array length is 1, can we say that when array length becomes 1, right, at that point what we have is this we can do this. So let's say this we trick this, right, a bit. Let's say instead of using that base case, what we do is, now that we have first element in the array, right, we will see if it match with the target, right? So let's say the first element is the target. In that case, we will return true, right? Right. Otherwise, we'll call the same function. Okay, makes sense. And let's run what happens. Okay, so we can see here, right, 75 does not exist in this array, right? So what it will do is, like, we're slicing this problem into sub problems, right? And so it's gonna go to one element at a time. So it's gonna return false here when array length becomes less than equals 0, right? And that's why we're getting false here, because it does not meet this condition, right? So at some point it's gonna go one element, and then we're not covering that use case where array element is length 1, right? So basically it's gonna call again, and the array length would become empty, and we're returning that case, right, false here. Because we know when array element is false, array has no element, it should return false, right? And that's the reason why it's returning false. But this condition is passing is because of this base case, right, where when we are removing the first element, each time we're comparing if 1 is the 75, if 65 is 75, if 3 is 75, sorry, 65, right? So in that case, this condition will met when we have array size 0 has a 65 element, and we're comparing again 65, then it returns true, right? Okay, so that's second problem that we solve. And let's go next, right? Okay, let's change this function to count the occurrence, right? So it's the same function, right? So we want to see how many times 75 appears in this array, right? So now in this case, instead of returning false, if we don't find the 75 in the array, we return 0. If array is empty, it's 0. If we find 65 one time, then it should return 1. Let's say if there are multiple 65, let's say there's another 65 here, right? In that case, this should return 2, right? So now we change this to number, it returns number. In case of invalid, it returns 0, right? There are 0 occurrences if array is empty. Now, how do we count if there is an occurrence, right? So we can use the same value here, right? And what we can do here, instead of returning true, we use this recursive case, right? And we append 1 on front, right? Why did I do this, right? What I'm trying to say here is that if the head element is the target element, then count 1 occurrence, right? That's the idea, right? If I don't find it, then I'm just gonna slice the array into subproblem, but I'm not counting anything, right? Now this means that, right? It's basically same thing, right? If you do 0 plus here, it's gonna be same thing, right? So I'm gonna remove this, right? And now if we check, you can see, right? The 65, it appears 2 times in this array, so that's why it's returning 2 times, and the other 2 cases are invalid, right? So that's how we can solve that problem. Again, let's do another problem, right? So this is a different problem. So in this problem, so what we want to do here is that we want to reverse an array, right? Let's say this array is 1, 2, 3, right? So when you reverse, it should become 3, 2, 1, right? If somebody pass invalid array, right? Let's say somebody pass empty, then we return empty array, right? Because empty array, reverse of empty array is same, right? Okay, we remove this here. We change the name of the function, and we return array of numbers, right? Okay, so how do we do this? Just think about this, right? So first we cover the base case. And what's the base case? When array has invalid size or empty array, right? So in this case, let's say that if array dot length less than equals 0, right? In that case, we'll just return empty array. So we cover this case, right? When array is empty or invalid, right? Now, we need, how do you reverse an array? I'm giving you one hint here. Okay. So let's say that what if in head to tail array, like, okay, let's try the recursive case here first. So let's say return, right? And in the head to tail approach, what we do is we take this array and we slice the problem into subproblem, right? So we basically remove. So we're removing the first element. Let's say I remove this element, right? So what if the removed element, I put it on the back? What happens, right? So if I do that, so when I remove 1, I put it back. When I remove 2, I put it back. So it becomes 3, 2, 1, right? You can clearly see, right? So basically, let's say we create a new array. So basically what we're doing here is that we're spreading this array, right? Like we're creating array from this slice. For example, when you call this function with 3, 2, 1, what we are doing here is that we removed, and we are calling 1, 2, 3, right? So now when we call array slice 1, we're removing 2 and 3, right? But we're not using this 1 anywhere, right? How about we use that, right? So let's say that if we use arrays 0 element, right, in the same array, what happens? And we want to put it at the end, right, and see what happens. You can see now it's changed, right? It's reversed in the correct order, right? What we did is we know that we spread the tail first and then we put the head back, and that's how you can easily reverse an array, right? Okay, so let's go next. Let's create a function that returns true or false if array is sorted, right? So let's create a function called isSorted. The idea is that, let's say if this is a sorted, right, because it's increasing order 1 2 3, so this should return true. For empty array, let's assume that it is already sorted, right, because there are no element to sort. We can also take one more example. In this case, let's say this is not sorted, 4 4 5 5 6, right? So this should return false, right, because it is not sorted. Okay, so let's try with the base case first, right? So in the base case, what we're trying to cover is if array's length, or we can say less than equals 1. If array is size 1, it is already sorted, right? For example, if I take another example here, and if I pass, let's say 5, right? So you can say that array with a 1 value, it is already sorted. There's no other value to compare with, right? So in that case, we return true, right? So basically, this line of code, I have to change this to Boolean, right? And then we call the same function, return sorted, we slice the array from the first element, right? Okay, we're not done yet, right? We're not done yet. So basically this line covers these two cases where the array element is either size 1 or empty, right? So that covers this, but we also have to cover the case where it is not sorted. And how do you figure out if array is sorted? So each time we're slicing the first element, right? So maybe let's say you can use this sliced element, compare it with this second element, right? And if you do that, then you can pretty much say that if array is sorted or not, right? For example, here, when you compare 5 with 6, you can say, oh, okay, it is sorted, right? Because 5 is less than 6. But when you compare these two, you can say 6 is greater than 1, so that's false. So let's cover that scenario. So what I want to do here is that the sliced element 0, I'm comparing it with the next element, right? I mean the first element. If both are the same, it will return true, right? Otherwise, I'll call the same function and wait until the array size becomes invalid and it returns true. But hold on, here it's a glitch, right? If we return true here and true here, then it's a problem, right? So we had to return false. Let's say that the array first element is greater than this guy, then we return false, right? And if we run this, we can see if array is 0 element, which is 5, greater than 6, return true. Well, it should return false. Sorry, it should return false. Okay, so now you can see it's false, true, 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 right? So yeah, that's the idea. Let's try another function. Let's say that given the array, we want to remove the duplicates, right? So we will create a function called remove duplicates, and we will pass, let's say 1 2 3 4, right? So this covers non-duplicate code, right? So this should return false because now we just want to return non-duplicate values, right? That's all. So this should return 1, 2, 3, 4, right? If we take another example, in this case, let's say that we have multiple duplicates here, 4, 3, 2, 1, right? But this should return 1, 2, 3, 4, the unique elements in the array. What if the array has a remove, let's say remove duplicates, but we pass the invalid array, right? So in this case, it should return the same blank array, right? So let's call this function that. This returns number array, right? We covered the base case. Even if, let's say if we have one element, it is already unique, right? Let's say we have maybe 5. In that case, this is unique, right? So let's say that in this case we will return array 0 value, right? Sorry, we will return the same array, right? So we don't have to do that. So in that case we'll return that. Remove duplicate function. Okay, right, so now we need to cover the case where we had to remove the duplicate. So how do you find the duplicates, right? So we can take the same approach that we took before, right? So basically, let's say we compare the first element. If it is similar to its next element, right? Sorry, I'm just changing this because this function should check if there's a consecutive duplicates, right? 2, 2, 2, 3, 4, right? That's how this problem is basically only for like the shorted array, but it has the duplicates, right? So in this case we check if there's a neighbor, right? Like if the neighbor is the same element, in that case we'll call the same function, right? We shrink down the problem. Otherwise, if it is not the same, right, then what we want to do is we want to create a new array and spread the rest of the element, but we also have to consider the first element, right? So in that case we will put this 0th element here, right? So we have to include the head plus del, right? If you don't include head, then you get nothing, right? You get the blank array. So let's run this code. See, you can see it has a unique, right? As I said before, if you don't include this 0, what happens? See, you get only the last element, right? That's why it's important to include the head in this head to tail approach. Okay, let's solve another problem. So let's say that we want to check if given okay, so given the function called isPalindrome, which has array of strings, let's say some example. So let's take some example like this. Okay, so let's try with the invalid first, right? So in this case we'll return the blank array is already palindrome, right? In palindrome you have to check if the given array elements, they're same, right? It reflects the mirror image, right? For example, let's say a, and this should be string. I'm gonna remove this so that it is clear what we're doing. Okay, so let's say A and B, A, right? So in the palindrome, you can say that this is true. Why is true? Because let's say if you put a mirror here, right? Like, let's say this is a mirror, right? You can see on left and right, both have the same elements, right? So that is called palindrome, right? Let's take an invalid example. In this case, let's say this is C, right? So when you look from here, the C and A on left and right, they're not equal, right? And that's the reason why this string is not palindrome, right? Like this character is not palindrome in this array. So this is how we had to check, right? All right, so let's do this. So first we tackle the base case. So in the base case, what we do is we check if array length is base case array length is array is invalid, right? Or has single element, right? So if array dot length less than equals 1, in that case we return the same array, right? So in that case we return true, because this should return boolean. We want to check if it's true or false, right? That's why we have to return true or false. Okay, now we care about the recursive case, right? So this is a must, right? So we have to do this step in all array problems, right? When we are using head to tail approach, right? But where should we put this? And that's a different question, right? Okay, so how do you check if this and that string is the same, right? So the way you can do is, because it's a first and last check, right? So we can say, we know that we're slicing the first element, but we still have the rest of the array, right? So like this. So we take the last element and we compare it with the first element. So let's say array first element, if it's triple equals array's last element, array dot length minus 1, because it's a zero base index. If we find that the first and last element is the same, right, in that case what we want to do is we're going to return true, right? But we also need to cover the case where it's a false, right? So how about we do this instead? Right? Okay, so what are we doing here? So we're checking to see if first and last element is same, right? If it is the same, then it will call the next function. Otherwise, it will return false right away, right? Because we don't want to call the same function again and again if we don't meet this condition, right? So this is like early exit, right? So that's a recursive. Basically, we want to save some time. That's the idea. Okay, let's run this code, and we can see true, false, false. Okay, hold on. So first, this is true. That is true. Oh, hold on. So what we need to do, sorry. So when we compare first and last element, we also have to remove the last element here. Otherwise, we're comparing with the same last element. That's the reason why it's giving me a false value. Okay, so now it's true, true, and false, right? And this is false. Okay, so that's one more adjustment here, because we were only comparing with the last element, but we're not removing that in each call. Okay, so let's go let's try to solve another problem. So basically we're going to solve another problem. So we want to rotate an array. So let's say rotate array to right. Okay, and how do we do this? So for example, let's say that you are given this array. Okay, this number, and we also expect the same rotated array, right? Okay, so let's try this two case first. So basically what we want to do here is that let's say given this array and there's another argument, let's say it's given 2, right? Let's say it's 2, right? And this is a k. So we want to rotate array by k elements, right? That's the idea. So when we rotate this element 2 times, what do we get? So the 3 goes in the beginning first time, and then from here it's gonna go like this. So the output for invalid, we're gonna return the empty, right? And for valid, what we're going to return is the rotated array, right? So let's rotate this array first time. So when we rotate this array first time, what happens? So the 3 comes first, right? So it's gonna be like this: 3, 1, 2, right? If we rotate this again one more time, then what happens? This 2 comes in the front, right? And we remove 2 from this, so it should be like 2, 3, 1, right? So it should return this. So we need to rotate this element 2 times. So the idea is that we take the last element and we move k times in the beginning, right? So that is the idea. Okay, so let's tackle the invalid case first. In this case, what we want to check is if when k becomes 0, because we are also going to reduce k. So if k becomes 0, or if we have array length is invalid, let's say 0, then what we want to return is the array itself. You can also say that, let's say if array has a single element and you rotate it by k times, it's the same element, right? It's rotated the same element again and again. Okay, so now we tackle the recursive case, right? So in recursive case, what we do, so rotate array to right, we take this array dot slice first element, right? Okay, so if you remember, so what we are doing here is that we're calling the same function by shrinking the problem down, but we're not rotating the array right now. So we need to rotate this array, right? And the way we rotate the array is that it requires the array argument, right? We need to pass k as well. Sorry, k as well. So let's say the first time, and we reduce the k by 1, right? Each time we call this function, we reduce k, right? That's why the k, when k becomes 0, we return the same array, right? Okay, so now what we had to do is, instead of passing the tail, right, we will do is remove the last element. What is the last element in the array? So we put that element first, right? Array dot length minus 1. So we put the last element first, and then we spread the rest of the element, right? If we do this, then what basically we are doing is that each time we're reducing k, and also we're taking this number and put it in the front, and rest of the element in the after, just like how we reverse the array, right? It's a similar concept here. So let's do this, and you can see, okay, did I do something wrong here? oh, we don't need to slice here, we need a full array, right? And so in this case we have to start from 0, and then we have to remove the last element, right? Each time we have to remove the last element and put the last element front. Okay, so now you can see it's correct, right? 2 3 1. Okay, so and lastly we solve one more problem and then we are done with this tutorial. So let's change this function and call it missing number. So idea is that if we have an, I'm gonna also remove this k, remove this as well. So idea is that let's say that we want to return a missing number from this function, right? Let's say if array is blank, right? And there's no number missing here because there are no elements. So in this case we return, let's say 0, right? There are no missing. Either we can return 0 or maybe -1. Let's return 0. And let's say we have array like this that start from 0 0 1 2 and 3, right? So in this case there are no missing element, right? So we return 0. And also let's say we miss number 2, right? In this case it should return 2 because that's the number that is missing from this array, right? Okay, so let's start. So first of all, what we want to do here is that we want to reduce the problem by 1, right? So how are we doing this? Return so I believe in this case we cannot take the head to tail approach, but we can tail to head approach, right? So idea is that like each time we will increment the index. So let's add a index, right? So we will start with the first element from the array, right? Plus 0, right? So we'll start with the initial index, right? And let's say we call the same function, we pass the array, and then each time we will increment the index, right? Why do I do this? So basically we want to look through all the element in sequentially, right? From the beginning. We can't come from the back because that's not the good approach, right? If we want to check the missing number, we have to check the ascending order, right? That's the reason why I'm going in this linear direction. So at one point, if I'm going like this, so I'm looking for first element, then going second, third, fourth. At one point, I'm going to run out of the array index, right? So what I will do is I'm gonna make check here if index is greater than or equals array length, right? If I'm exceeding the array, then I should return array.length, right? I should exceed the array length. And let's run this code. Right now this it's not going to return the correct answer. All I'm looking for is that it should return the array length, in this case 0, in this case 1 2 3 4, and in this case 3, right? Oh sorry, I missed the return. See, that's the reason why it's gonna go infinite if you forget the return. Alright, so you can see it's returning the array length, right? Now how do we find the missing number? So can we say the index, each time we are incrementing index, it is going to be in increasing order, right? For example, index is initially 0, then it's going to go 1 2 3 4 and so on, right? And if we look at our array, it has a similar pattern, right? So we can say that if index not equals array index, right? The element at the same index. If it's not the same, um, let's say that when we are at 0 index, and if element is not 0, then that's a missing number, right? So at that point we can return that index. So that's our missing index, right? Otherwise we'll call the same function. Okay, so in this case, I think this is invalid. Instead of returning array length, we can just say maybe let's -1. If we exceed the entire array, we will return -1, right? And this is also, let's say instead of 0, -1, because 0 might be a valid missing number, right? So let's say here -1. If there are no missing number, we return -1, right? And if there is a missing number, we return that missing number. So in this case, if array is empty, we return -1, so that is correct. In this case, there are no missing number, we're returning -1, that is also correct. And in this case, we have 2 missing, and that's why we return 2, right? We can take another example. And let's say in this time we have 0, 1, 2, 3, and we are missing, let's say 3. So that's correct, right? It's returning correct. So I hope you like this tutorial. Please like, comment, and subscribe, and stay tuned for my more videos. Thank you.